Okay, so we did the power rules where if I multiply, I end up adding the powers, because this is like x times x times x times x times x, and so altogether I have 5x's being multiplied. And we did power on a power, where x squared cubed means x squared times x squared times x squared, or x times x times x times x times x times x. And basically what I'm doing is I'm counting my x's. And so again, when I'm multiplying with the like bases, I end up adding the powers, but when I'm taking a power on a power, I end up actually multiplying the powers. Well, we're getting into division now, and when we divide, maybe you caught this on the other video, or on the video that you were working on Friday, you actually end up subtracting. So x to the n over x to the m is equal to x to the n minus m. Well, that's not that effective of a rule until you sort of see it in action. So if I see it with numbers, if I have x to the 4th over x to the 6th, that's x to the 4 minus 6, or x to the negative 2nd. If I end up with a negative power, that moves down to the bottom and becomes positive. All right? So you guys need to have your devices away and be paying attention. Because we have to do that extra move where a negative power moves to the bottom and becomes positive, what I do is I treat this a little bit differently. I look at this and say, where are there more x's and how many more? There are more on the bottom, and there are 2 more on the bottom. So my final answer is going to be 1 over x to the 2nd. Now, if I add values into this, like I have numbers in some of my problems, like I do in 1, and actually in our examples, those numbers still get treated just like normal numbers, the 6 and the 5. If you can reduce them, reduce them. So the 6 is still going to stay on the top, and the 5 is still going to stay on the bottom because I can't reduce those. But then I'm going to look at the letters. I have 5 m's on the top, 8 m's on the bottom. That means I have 3 more m's on the bottom, and that becomes my final answer. So in problem number 2, the 7 and the 5 stay. They can't be reduced. I have 7 m's on the top, 6 m's on the bottom. That means I have 1 more m on the top, and that again becomes my final answer. Do I need to write it as m to the first? No, this would just be 7m over 5. So it's just, where do I have more, how many more? That's all I'm looking for on these. Now, problem number 3 is slightly different because we can reduce the 6 and the 2. And so I reduce it just like a fraction. And if you suck at fractions, if fractions aren't your thing, remember we spent the first 2 weeks dealing with your calculator, and we did it last year. How do you plug a fraction into your calculator? How do you reduce it? How do you make sure it's improper? So if you can't figure out how to reduce that particular fraction, plug it in. 6 over 2, it should come out as 3 over 1, or 3. That means I have 3 left on the top, 1 left on the bottom, and then I look at the variable. I have 2 more n's on the bottom, so I make it n squared. So this is 3 over n squared. That's a bad color, hey? Hard to see. I'll go to a different color. If I don't have numbers on both parts, then I just leave the number where it is. In problem number 4, I have 10 p's on top, 2 p's on the bottom. That means I have 8 more p's on top. There's my final answer. So it's just about subtracting. Let's say, like in problem number 5, I have 2 variables. Well, then I treat the variables as separate. So I can reduce the 10 and the 5. That leaves me with a 2 on the top. I have 1 more x on the bottom, And because I have the same amount of y's on the top and the bottom, I just cancel that out. So my final answer here is 2 over x. All about subtracting the powers. In number 6, because I don't have any other n's, the 8 and the 9 can't be reduced. The n is going to stay on top because it doesn't have anything to combine with. The m's, I have 3 more on the bottom, so I write it as 8n to the 10th times 9m to the 3rd. If I have multiple numbers, I'm still going to, like we did before, if I have situations where I can combine, I have n to the 8th and n to the 3rd, well, that's like my last week's stuff. I'm going to add those powers together, and on the bottom I'll do the same thing. Multiply the big numbers and add the powers together, because remember that's n to the 1st. Once I get it all simplified on the top and simplified on the bottom, then I can do the division part of it. I can reduce the 10 and the 12. That's 5/6. As for the n's, I have 4 more on top. So combine the tops and the bottoms first. I couldn't do it in 5 and 6 because I had all different variables, but here, because I have matching variables, I can combine. So this next one is 7v to the 9th over 50v to the 18th. 8 plus 10, add those together, they're on the same level. Then I simplify if I can. I can't do anything with the 7 and the 50. I have 9 more v's on the bottom. There's my final. So it's really just a matter of subtracting your powers. All right? Any questions?